So question number one, a rocket is rising vertically at a rate of 880 meters per second. And so that's going to be my dy by dt when it is 4,000 meters up. So that 4,000 represents my y positioning. A person observing the rocket at 300 meters from the launch site. So that's going to be my horizontal positioning. So if you can take a look at the picture down here, this represents the, the situation that I'm dealing with. And it says, how fast is the angle beta of elevation changing from the observer? So I want to know how fast this angle is changing as the rocket ship is moving up at a rate of 880 meters per second. Okay, so the first thing is I need to connect the two quantities that I need involved here. I've got my dy by dt, and I need to find d beta by dt. That's what I'm looking for. So I need some relationship that connects the beta to the y positioning, and that's going to be tan. So I'm going to write like this, my y height divided by the 3,000 meters. That ratio is going to be my tan ratio for angle beta. And then I just need to differentiate this to generate my dy by dt and my d beta by dt. So I'm going to have 1 over 3,000, and then differentiating my y, that's where I'm going to generate my dy by dt, because y is a function of time, so it's an embedded function. And that's going to be equal to the derivative of tan is secant squared, and because I have my beta embedded, and beta is a function of time, I'm going to apply my chain rule and generate my d beta by dt. And so that's what I need to know. I need to find d beta by dt, and I know I've been given the 880 meters, so that's going to be meters per second is going to be my dy by dt. It's going to be 1 over 3,000 meters. I need to work out the secant beta to be able to solve for d beta by dt. Now I can work out beta based on this diagram, but since secant is a hypotenuse over adjacent side, or hypotenuse over x, I really just need to find the hypotenuse, and I can actually directly input the secant value instead of finding the beta value. So if I use Pythagoras, I get 5,000 meters along this hypotenuse, and then the secant beta is going to be the hypotenuse, 5,000, divided by the adjacent, which is 3,000. So I'm going to simplify that to 5 over 3, and that's going to be squared. So that 5 over 3 represents the secant ratio. And then I need to solve for d beta by dt. So now I've got my equation where the only thing unknown is d beta by dt. So when I solve for this, I get d beta by dt is equal to 880 over 3,000, and then I'm going to divide by 25, or I have 25 over 9, so I'm going to multiply by the reciprocal on the other side. 9 over 25, and then I can simplify that expression. Just going to use my calculator here to simplify this expression. I get 880 times 9 divided by 3,000 divided by 25, and that's going to give me 0.1056, and that's going to be radians per, in this case, it looks like seconds is my time frame.